Hi, thanks for joining. I'm Ben Andow. I'm currently at Google, but when this work was completed, I was at North Carolina State University and IBM Research. So in this talk, I'm going to discuss our work on measuring the consistency between data flows within mobile apps and the disclosures within the app's privacy policies. So before we start, I want to include a disclaimer. Again, this work was completed while I was at NC State and IBM Research, but I am currently employed with Google. However, none of this work or statements within this presentation reflects the views of Google and should not be construed as statements from Google or from my current role as a Google employee. That is, I am in no way, shape, or form representing Google in this presentation. So let's get back to it. So it's fairly common knowledge that apps collect user data. So here's an example of one such Android app called Skyfighters 3D that has 10 million downloads on Google Play. We analyzed this app using AppCensus, a dynamic analysis tool, and found that it was sending various device identifiers to two advertisers, namely Tapjoy and Flurry. So the question that we seek to answer in this research is, are these data flows disclosed within this app's privacy policy? Therefore, we look at the privacy policy and we see the following statement that essentially says, we collect MAC address, IMEI, and unique device ID. However, nowhere in the privacy policy does it ever mention sending these identifiers to advertisers, third parties, or anything along those lines. Therefore, we consider this data flow as inconsistent with its privacy policy. And these are the types of problems that we're seeking to identify in this work. So we're not the first to touch upon this topic of flow to policy consistency. There's been three major works in this area. However, we identify one significant limitation of these works, and that is they perform entity insensitive analysis. In particular, that means that they don't consider the entity behind the data flows or policy statements, and in general, just check whether the data types are mentioned within the privacy policy. And this causes significant problems. Therefore, in that prior example, they would have actually incorrectly marked this data flow as consistent with its privacy policy. We actually perform a sensitivity analysis in the paper, and we find that entity insensitive analysis may result in reasoning over up to 56% of data flows with irrelevant policy statements, and also misclassifying up to 37% of data flows as consistent, when in reality, that is not the case as shown in that prior example. So for further details on that experiment, how we set it up, and exact details on our findings there, please refer to the paper. So this work has two main goals. First, we want to formally specify a flow to policy consistency model that is entity sensitive due to the importance that we showed in the our sensitivity analysis. But also we want it to be sentiment sensitive, which means that we want to know whether the policy is talking about collecting or not collecting data, or sharing or not sharing data. And it also needs to be contradiction sensitive. That is, we want to know whether the policy has conflicting statements, which means that we can't look at the first mention of a collection or sharing statement, but we need to consider the policy as a whole when performing the analysis. And the importance of those latter two properties, that is sentiment and contradiction sensitive analysis, you can find the details of that in our USENIX security paper last year called Policy Lent. And we also want to perform a large-scale empirical study to characterize the space of disclosures and violations in a large ecosystem. And in particular, in this study, we look at we perform an analysis of Google Play applications. So we propose a system called PoliCheck, which contains a entity sentiment and contradiction sensitive data flow to privacy policy consistency model. It is actually built on top of PolicyLint, our USENIX security tool, our paper at USENIX security that extracts policy statements, and AppCensus, which extracts data flows. We propose various techniques and extensions to these tools to link the results together, and we provide a formalization to reason over these inputs. So again, you can see the papers for complete detail on these approaches. So PoliCheck classifies data flows as 5 different types of disclosures, because our goal here is to characterize the space. And in particular, there's 2 different types of consistent disclosures, clear disclosures and vague disclosures. So clear disclosures are the ideal case. So they discuss that the flow occurs in exact terms. So for example, there's this app shown below that collects ad ID and sends it to Unity, and their privacy policy explicitly states Unity collects ad ID. as you can see at the bottom of the page, that's an excerpt of our formalization. Again, if you want to know the exact notation and how we define each type, please refer to the paper. A vague disclosure is another type of consistent disclosure, but instead of using exact terms, they discuss that the data flow occurs using broad terms for the entity, the data type, or both. So for example, if we see ad ID going to an advertiser Tapjoy, the privacy policy could state something along the lines of device identifiers may be shared with advertisers as shown in that example below. So vague disclosures are not inherently negative. However, we do show later on in the findings that they can lead to some problems when considering specificity requirements of certain regulations such as GDPR and CCPA. With that being said, we actually propose a vagueness metric within the paper to quantify the vagueness scores of each of these disclosures, but the details of that are in the paper. Finally, there are three different ways for inconsistencies to occur, and those are omitted, incorrect, and ambiguous disclosures. So an omitted disclosure basically just does not disclose the data flow within the privacy policy. So for example, we found this keyboard app that has 50 million plus downloads on Google Play that collects the ad ID, IMEI, and phone number and sends that data to an advertiser called Avazu. Their privacy policy never discusses sharing of this information at all. They do mention collecting device identifiers as shown in the excerpt on the right. However, they omit these data flows to Avazu in their privacy policy and therefore are inconsistent. It's also worth noting that the prior approaches would have also incorrectly identified this as consistent. The second type of inconsistency are incorrect disclosures, which basically just discusses that the data flow does not occur in the privacy policy. So for example, there's this app called Furby Boom that has 10 million plus downloads on Google Play that's actually offered by Hasbro that collects the IMEI and sends it to Unity. Their privacy policy states our apps do not send device ID to any third party, which is clearly in conflict with the data flow. And finally, ambiguous disclosures discuss that the data flow both occurs and does not occur. That is, there's a contradiction within the privacy policy. So there is a flip diving app on Google Play with 50 million plus downloads that takes the ad ID and sends it to Ad Colony. And their privacy policy states our apps, on our apps, these third-party advertising companies will collect and use your data to provide you with targeted advertising. However, later on, they also state we don't give or sell your data to third parties for them to market to you. Therefore, their privacy policy is contradicting itself and therefore is ambiguous. And PoliCheck classifies it as such. So we use PoliCheck to perform a large-scale empirical study on around 13,800 Android apps. And AppCensus found that they had 45,603 data flows. For details on our selection methodology and more details on our data set, you can refer to the paper. And we're going to go over some of our high-level findings. Again, if you want details on our findings and for a complete list, please refer to the paper. Overall, we found 43.5% of flows were inconsistent with the privacy policy. We even found that some apps had over 15 omitted or incorrect disclosures. We dug into some of these apps in the paper as case studies. So if you're interested in these highly inconsistent apps, please refer to the paper for details. We found 49.5% of apps were disclosing their third-party sharing practices using vague terms. Again, recall earlier that we said this is not always inherently negative. However, when looking at the data flows in the statements that were disclosing them, we did find some concerning practices. For example, we found a lot of third-party flows involving ad IDs and Android IDs that were flowing to different companies, as shown in the heat map, that were disclosed by statements such as third parties collect PII or third parties collect info. So this raises concerns on specificity requirements of GDPR and CCPA that discusses that they must disclose categories of entities that they are sharing data with and categories of the data types collected. However, further exploration is needed into these vague disclosures. We found 719 apps making incorrect statements about their data practices. So they were saying that they do not perform some behavior when in reality, the dynamic analysis showed that they actually did perform that behavior. Android IDs and ad IDs are, again, the most common, and third-party not collect PII accounted for 63.5% of these disclosures. We found 8% of apps have ambiguous privacy policies. For one example is at the bottom there, where the application collects the Android ID, and their privacy policy both states, we do not collect unique identifiers, and later on they state, we use anonymous identifiers, so the privacy policy is contradicting itself. Finally, we found 31.1% of data flows were classified as omitted disclosures. This finding raises questions on developers' understanding of third-party SDKs, on what these SDKs are doing when they include them to their app, and also on their responsibility for disclosing these privacy practices. So it's worth noting that PoliCheck had a bit lower precision for omitted disclosures, but the paper discusses that this may be indicative of confusing policy language, and you could refer to the paper for an explanation of this. So in general, we had a overall 90.8 precision. As mentioned before, we had a bit lower precision on omitted disclosures. Again, please refer to the paper for details on our evaluation. So again, PoliCheck provides a flow to policy consistency model that is entity sensitive, sentiment sensitive, and contradiction sensitive. The code is available and open sourced on GitHub, so feel free to run our tool or to check out the source code. If you have any questions, feel free to reach out, and I will answer as best as possible. Thank you very much for your time, and thanks for watching my talk.